So, here's a question for you. What if the world's most ambitious projects, the stuff from sci-fi, had actually been built? Structures so massive they'd redraw our skylines, maybe even our coastlines. These aren't just fantasy sketches, these were real, detailed plans, backed by architects, backed by engineers, backed by governments. They were on the drawing board, ready to go. Then they hit a wall. Usually money, often politics, or the limits of physics. Alright, first up, let's talk about a project that would have literally redefined the skyscraper. We're going to Chicago, 1956. The legendary architect Frank Lloyd Wright, a man who was never short on big ideas, unveils his masterwork. The Illinois, detailed blueprint and proposal. This wasn't just another tall building, it was conceived as a mile-high tower. That's 5,280 feet, or about 1,600 meters. 4 times the height of the Empire State Building, and almost double the height of the Burj Khalifa. It's an absolutely staggering scale to even think about. The design itself was pure Frank Lloyd Wright, a slender tripod-like structure that tapered as it rose, designed to be aerodynamic and stable against the infamous Chicago winds. He envisioned it as a complete city within a building. It would have housed 100,000 people. Offices, apartments, schools, hospitals, vertical farms. The goal was to decentralize the city, a self-sustaining community rising into the clouds. So how would you even get around a building this tall? Wright had an answer for that too. He proposed atomic-powered elevators. 5-story high external elevator cars, shooting up the building's exterior at speeds up to 60 miles per hour. It sounds like something straight out of a sci-fi novel, but he was serious. The technology of the era just wasn't quite there yet. Material science, elevator tech, wind engineering. Ultimately, the Illinois remained a visionary concept. Frank Lloyd Wright passed away soon after. The project died with him. Its legacy lives on in modern supertalls. It remains one of architecture's greatest what-ifs. Next, we head over to Moscow in the 1930s. The Soviet Union, under Joseph Stalin, wanted to make a statement to the entire world. They wanted to build a monument so colossal and so grand that it would symbolize the triumph of communism. Their answer was the Palace of the Soviets. It was a neoclassical masterpiece, a tiered wedding cake-style skyscraper. It would have soared to 415 meters. The entire structure was designed as a pedestal for a 100-meter-tall statue of Vladimir Lenin, taller than the Statue of Liberty. Inside, the palace was designed to be just as grandiose, a cavernous amphitheater to hold over 20,000 delegates, topped by a dome with a 100-meter span. It would include museums, libraries, government offices, the political heart of the Soviet Empire. To make way, the original Cathedral of Christ the Savior was dynamited in 1931. The site was cleared, the foundation laid, and the skeleton began to rise. But in 1941, Nazi Germany invaded. Construction was immediately halted. Survival became the priority. Steel was dismantled for bridges and defenses. The foundations became the Moskva pool for decades. After the fall of the Soviet Union, the cathedral was rebuilt, erasing the last physical trace of this megaproject. So, if you thought a mile-high skyscraper was ambitious, let me introduce you to the Exceed 4000. Proposed in 1995 for Tokyo, it wasn't just a building. It was a man-made mountain. Planned height, 4,000 meters, just over 2.4 miles tall. It would have been taller than Mount Fuji. The scale is almost incomprehensible. The design was a massive pyramid-like cone. The mountain shape was a structural necessity. The base would be 6 kilometers in diameter, about 3.7 miles. It would need to withstand immense wind pressures and Japan's seismic activity. Conceived as an arcology, a semi-enclosed city to house up to 1 million people. Lower levels, commercial and office, residential, upper levels, parks, forests, and artificial landscapes, a controlled climate inside. Moving 1 million people would need systems beyond elevators, high-speed maglev trains inside the structure. Powering it would require massive energy, likely solar since it would rise above the clouds. The steel and materials required would be staggering. Projected cost, $300, $900 billion in 1995, over $1 trillion today. Conceived by Taisei during Japan's bubble, a visionary thought experiment and marketing tool more than a build plan. After the bubble burst, it faded from view. The tech and cost made it impractical with 1990s technology. It remains a benchmark for architectural ambition, the peak of megastructure imagination. Okay, let's move from building up to building on water. This next one is the Freedom Ship, a floating city, a colossal vessel, a permanent mobile community. Imagine a slice of a major city, homes, businesses, schools, hospitals, constantly circumnavigating the globe, over 4,500 feet long, 750 feet wide, 350 feet tall, nearly a mile long, too large to dock, anchored offshore, smaller ferries and seaplanes would shuttle residents. Top deck, a full-scale airport, designed to be self-sufficient, permanent residences for 50,000, 30,000 daily visitors, 20,000 crew, 10,000 overnight guests. Interior highlights, shopping malls, schools, hospitals, parks, casinos, and sports complexes, built from 520 airtight cells, claimed stable and virtually unsinkable, estimated cost around $10 billion. Funding, legal and safety questions stalled it, so it never set sail. For this next one, we're looking at a project that was an extension of another famous megaproject, Boston's Big Dig. The Big Dig buried the elevated highway and reconnected the waterfront, creating parks and new urban spaces. But it didn't fix Boston's bifurcated rail system. Two major terminals, North Station and South Station, a mile apart with no direct rail connection. If you arrive at one and need to catch the other, you use the subway, a taxi, or walk. The North-South rail link proposed digging deep tunnels under the city to connect them. A Big Dig 2.0. Trains could pass straight through, transforming regional travel and unifying commuter and Amtrak networks. But tunneling would cut under historic, densely packed neighborhoods, existing foundations, and a web of utilities. Costs were expected to match the original Big Dig. After cost overruns and controversy, there was little appetite for another decade of disruption. Though advocates persist and long-term benefits were argued, political will and funding never materialized. The North-South rail link remains Boston's great unfinished transportation dream. Let's go back to Japan and another project born from the optimism of the economic bubble years. The Shimizu Mega-City Pyramid, proposed in 1989 for Tokyo Bay. It would stand more than 2,000 meters tall, about 6,500 feet. That's 14 times the height of the Great Pyramid of Giza, a self-contained city designed to house 1 million people built over Tokyo Bay, an open, truss-based frame to be strong yet lightweight, letting sunlight and wind pass through. Inside, smaller skyscrapers would be suspended from the main frame and connected by automated transport pods, escalators, and truss-mounted elevators. A three-dimensional city grid, distinct residential, commercial, and public zones. Major hurdle, materials. Conventional steel and concrete couldn't handle the scale. Carbon nanotubes were envisioned but remained theoretical. The base would be 36 massive concrete piers anchored to the seabed, and construction envisioned as robotic assembly of truss pieces. Power from solar arrays on the surface and energy harvested from ocean currents. But after the economic downturn, the project stalled. Immense cost and reliance on unproven tech made it untenable. Today it remains an influential, imaginative architectural concept, not just about height, about a new integrated way for 1 million people to live and work together. A highly speculative bet on future tech that captured the imagination of planners and designers. Our final project is perhaps the most audacious of all. It didn't just aim to build a structure, it aimed to reshape a continent. This is the Atlantropa Project, the brainchild of German architect Hermann Sorgel in the 1920s. He proposed a series of massive hydroelectric dams, the centerpiece being a colossal dam across the Strait of Gibraltar. By restricting Atlantic inflow, he estimated the sea would drop roughly 1 meter per year due to evaporation. Over a century or two, the sea could lower by up to 200 meters, revealing vast new land. New land would appear in places like the Adriatic between Italy and the Balkans, and between Sicily and Tunisia. Sorgel envisioned Neuland for agriculture, settlement and industry, even connecting Europe and Africa into Atlantropa. He proposed locks and canals to preserve shipping routes and even irrigate parts of the Sahara. He promoted the idea tirelessly. Models, exhibits, lobbying governments and the public, but the potential environmental impacts were unpredictable and potentially catastrophic, altering the climate of Europe and North Africa. The rise of Nazi Germany, World War II, and later the advent of nuclear power shifted priorities. The project lost momentum. After Sorgel's death, the institute faded. Atlantropa is remembered as one of history's most ambitious and terrifyingly grandiose engineering fantasies. So there you have it, 7 incredible world-altering projects that came tantalizingly close to reality. From a mile-high tower in Chicago to draining the Mediterranean Sea. Which colossal what-if do you wish had been greenlit? Drop a comment below with your pick. I'm genuinely curious which resonates the most. If you enjoyed this dive, make sure you're subscribed for more mind-blowing facts and explorations of science and engineering. Thanks as always for watching. Peace.